small non-rigid airships was launched in 1901 by Santos Dumont. The natives of Paris were astonished as he wheeled the cigar-shaped vehicle through the streets. At this early date, he proved to them that a floating ship could be steered as it hovered over the roofs of Paris. On one of his intrepid flights, Dumont landed in his own backyard where coffee was served before he continued his aerial adventures. A year later, Laborde left the ground in the first semi-rigid airship. Under the envelope which held the lifting gas, he had hooked on a keel. The Republic of France accepted it for military purposes. This was the first time a nation had acquired an airship. Meanwhile, Count Zeppelin started building completely rigid airships for Germany in the early 1900s. The Zeppelin line achieved a remarkable record. Up to the war, it transported 34,000 attached to it. The Army's TC-13 is almost half the size of the RS-1. It represents the latest refinements in design of non-rigid airships, even including accessories carried by the huge rigid ships. In coastal patrol, this type of blimp can render important services. One of the major necessities in modern naval warfare is a detailed knowledge of the location and strength of the enemy forces. The airship, therefore, is a valuable adjunct to the fleet. It can patrol larger areas. It is much faster than a surface scout cruiser. From its elevated position, it can observe more territory, cover more distance, see more accurately. The use of gliders as trailers on airships presents an interesting possibility. By way of experiment, 4 planes without engines are towed by an airship. It is possible to release the gliders at will, the ability of the airship to reduce its speed, and even to hover over a given spot. It is well suited for the pickup and delivery of goods. It can do this without landing. A demonstration and proof of this was staged over New York City. A blimp picked up Europe-bound mail from the tower of the Empire State Building. The ship for which the mail was intended had already set sail. After taking the mail on board, the blimp headed directly for the Atlantic coast. And here we see it catching up with a fast steamship already 6 hours at sea. It served long and well. Convoying the rigid Los Angeles are non-rigid blimps. In the rigid type, you get the full power of lighter-than-air craft. Instead of one gas bag used in the non-rigid ship, the lifting gas of the rigid ship is contained in separate compartments. Damage to one cell and the consequent loss of gas is therefore not a problem with a rigid airship, whose comparative size is impressive in this air parade. The Los Angeles made her first American appearance after her historic flight over the Atlantic. 10 years ago, she was marveled at because of her impressive dimensions. Today, she is only about 1/3 the size of Germany's new transatlantic airship. At one time, mooring of airships could not be effected without use of a dock. Thanks to the efforts of the Navy, we have in the short mast an adaptable unit which ensures mooring under the most difficult conditions. When the Los Angeles flew to the canal zone, it used the Patoka, stationed at Puerto Rico, as a base. Huge rings made of light alloys of high tensile strength give the airship structure inner stiffness. They are constructed in horizontal position near the floor. This diagram shows first auxiliary erection frames which lift the rings into position. In the case of the Macon, these rings are as high as a 14-story building. While the erection gear is holding the rings in final position, the connecting girders made of the same light but powerful alloys are inserted from movable platforms. The square panels formed by rings and connecting girders are braced by a system of diagonal wires. This constitutes the basic structure of the rigid airship. In 1931, construction of the Macon started in Akron, Ohio. It was a vast undertaking. All the knowledge of decades of accumulated experience were transformed in her design. She was the product of years of research and the result of great engineering genius. The American Navy and the aircraft industry joined forces in this impressive undertaking. To build the Macon-type ship, a gigantic dock was constructed. The floor area is 8 acres, big enough to cover a complete farm. The Macon was a large-scale venture, but its bigness is not without reason. In aeronautics, cruising range is dependent on gas content or lifting ability. For the first time in airship construction, the fin, actually as big as a house and lot, was fully erected and completed on the floor, then hoisted into position. The Macon was launched in the spring of 1933, and after exhaustive tests, accepted by the Navy later that year. She has a top speed of 85 miles an hour and a cruising speed and non-stop range of about 9,000 miles. The same care that went into her construction was exercised in the selection of her personnel. A crew, complete as that of a seagoing dreadnought, was assigned to man her. The captain is in supreme charge of ships like the Macon. He remains in the bridge or control car while the ship is in flight. Sailors patrol the decks and catwalks at regular intervals for purposes of inspection. Special officers in charge of navigation, radio, and meteorology are on duty on the bridge under supervision of the captain or the executive officer. In the galley, meals are prepared for 100 officers and men. The Macon is complete in every detail, even to comfortable eating and living quarters for its personnel. The Navy has perfected ingenious equipment and perfect technique for the rapid launching and recapturing of its airplanes. In the development of mooring equipment, the Navy made use of an important mechanical principle for the connection proper. They rigged the bow of the Macon with a cone designed to fit into a funnel-shaped masthead. The guidance is ensured by a cable arrangement. This represents the utmost degree of perfection and safety in anchoring an airship. The Los Angeles and the Macon are the vanguard of the Navy, to whom we owe much for the development of the airship. Lighter-than aircraft was slower in developing commercially than the airplane transportation. 30 years of pioneering in lighter-than aircraft are but as a day in the history of aviation. The As Charles Gray once said, airplanes breed like rabbits, airships like elephants. But no one looking from a long-range viewpoint can fail to realize the international significance of the airship. The career of the Graf Zeppelin foreshadows the future of lighter-than aircraft. Year in and year out, it has flown a regular transatlantic schedule, and these figures tell its story. Up to 1934, it flew 460,000 miles, carrying 8,900 passengers, or 23,000 persons, including the crews. Up to its pier. Passengers descend from the gangplank in much the same manner as incoming steamship voyagers. Under Dr. Eckner's command, the Graf circled the globe in 1929. Since then, it has crossed the Atlantic on the South American run with timetable regularity. The Graf Zeppelin makes more than 10 round trips between Germany and Brazil every year, with a complete absence of ballyhoo and a business-like succession of arrivals and departures. The schedules, prepared months in advance, are carried out like clockwork. Comfort on a modern commercial airship is comparable to hotel luxury. Unlike the airplane, there is plenty of room to move about, and seasickness is unknown in these steady-riding air palaces. This is a blueprint of the passenger quarters of a contemplated commercial airship. The staterooms are large and airy and kept free from food and fuel odors. The spacious dining and lounge rooms will accommodate at least 50 passengers. The promenade deck is wide enough for deck chairs, and because helium gas is not inflammable, smoking will be permitted in the club and observation rooms. The observation room will be located outside the ship's hull next to the control car, giving an unobstructed panoramic view.